students. Today we'll start with topic 4 of chapter 1 class 9th mathematics, irrational numbers. A number S is called irrational if it cannot be written in the form p by q, where p and q are integers and q not equal to 0. This is the basic definition of irrational numbers. It means that any irrational number, any number is irrational, or a number is irrational if it is not a rational number. That means if it is not satisfying the definition of rational number, definitely it will be an irrational number. Or we are having one more definition for irrational number, that is on the basis of decimal expansion, which we will see in detail after completion of the coming exercise 1.2. We will see decimal expansions of numbers in this class only. The definition for irrational number on the basis of decimal expansion is a number whose decimal expansion is non-terminating, non-recurring is irrational. A number whose decimal expansion is non-terminating, non-recurring is called irrational number. If a number is there whose decimal expansion is non-terminating and non-repeating or non-recurring, it is called irrational number. Example: root 2, root 3, root 5, pi, 0.10110110110 ... It is non-terminating, non-repeating. Now we have to note some things. We have to note something about these irrational numbers. That first point, Pythagorean proved root 2 to be an irrational number. Pythagorean proved that root 2 is irrational. Later on, Theodorus of Crine, a teacher of Plato. I hope you know the name of Plato. Teacher of Plato, Theodorus of Crine, teacher of Plato, showed that root 3, root 5, root 6, root 7, root 10, root 11, root 12, root 13, root 14, root 15 and root 17 are also irrationals. Afterwards, Lambert and Legendre proved that pi is irrational. So in this way we can say that root 2, root 3, root 15, pi and these decimal expansions are irrational numbers. Now after this we'll move to a definition of real numbers that we have seen in the form of chart in our first lecture video. Topic: real number. Let's see again. Real number: the collection of all rational numbers and irrational numbers together make up a collection of real numbers. The collection of all rational numbers and irrational numbers together makes up a collection of real numbers. Now real numbers contains rational numbers and irrational numbers. After this we have to note few points related to real numbers. Few points related to real numbers. Now note down, every real number is either rational or irrational. If we consider any real number, every real number is either rational or irrational. Every real number is represented by a unique point on the number line. Every real number can be represented by a unique point on a number line. Every point on number line represents a unique real number. A number line is also called real number line, and I hope you know what is number line. This is the picture of number line in which 0 is at its middle and 1, 2, 3, 4 positive numbers are on right side and -1, -2, -3 are on left side. This is some note about real numbers. Now our next topic will be locate some irrational numbers on number line. Locate some irrational numbers on number line. How to locate irrational numbers on number line? Locate some irrational numbers on number line. How will you locate? First, let's locate root 2 on number line. Let's locate root 2 on number line. For this, we consider a number line. On a number line, first step, on a number line, we mark a point O. On number line, we mark a point O which coincides with 0. That means at point 0, we mark O. This is the point 0 where we mark O. Consider a point A. Consider a point A on number line such that OA equal to 1 unit. This is point A and OA equals to 1 unit. This is your distance OA. OA is equal to 1 unit. OA is equal to 1 unit. We mark BA perpendicular to OA. We make BA perpendicular to OA and BA equals to 1 unit. At point A, we make BA perpendicular to AB. We make BA perpendicular to AB and BA equals to 1 unit. Then fourth step, we join OB, and by Pythagoras theorem, we join OB. What do we join? We join OB. How we join OB? Let's see. We join OB. And by Pythagoras theorem, we get OB equals to under root 1 square plus 1 square equals to root 2. Now, fifth step, using compass with center O and radius OB, we draw an arc intersecting the number line at point P. With the help of compass, we use compass with O as center. We consider O as center and OB as a radius. We make an arc which intersects at point P, which intersects the number line at point P. P represents root 2 on number line. We get point P which represents root 2 on number line. Students, this is the basic construction that we have seen, or the construction for location of root 2 on number line. You can see the video once again to get the concept clear and do the construction by yourself for root 2. And remember, this all construction work, whatever the construction work I have done here, this construction work should be done with the help of pencil and compass. Now, the next topic is locate root 3 on number line. Locate root 3 on number line. How to locate root 3 on number line? To locate root 3 on number line, first of all, you have to consider a number line. We consider a number line. What are the steps for construction? We consider a point 0 as O on number line. We consider point 0 as O on number line. We mark point A such that OA equal to 1 unit. We make BA perpendicular to OA and BA equals to 1 unit. We join OB and we get OB equals to root 2 unit, like in the case of root 2. At B, we make DB perpendicular to OB. We make DB. Till this root 2, it's already we have studied in case of root 2. OB equal to root 2. At point B, we make BD. We make BD perpendicular to OB. We make BD perpendicular to OB, or DB perpendicular to OB, and DB equals to 1 unit. After this, we join OD, and by Pythagoras theorem, we get OD equals to under root 2 square plus 1 square. That means under root 2 plus 1 equals to root 3. So we get OD equals to root 3. What we get? OD equals to root 3. We get OD equals to root 3. After that, using compass with center O and radius OD, we draw an arc intersecting the number line at point Q. Intersecting the number line at point Q. Now with O as center, we'll consider our center here, and OD as radius. We make an arc which intersect the number line at point Q, and we get in step 8 Q, which represents root 3 on number line. This is representation of root 3 on number line. In this way we can locate root 3 on number line. Now there are something for you which you will try by yourself. Now you can try to solve these questions. Which questions? These questions. Solve it by yourself. You solve it by yourself. Root 5, root 6, root 7, root 8, root 10, root 11. Now hint for root 5 and 6. Root 5. Take OA equal to 2 unit, AB equal to 1 unit, and you will get OB equal to root 5 unit. Take root 6. In case of root 6, take OA equal to 2 unit, AB equal to 1 unit, BD equal to 1 unit, you will get OD equal to root 6 unit. And you can continue to proceed in this way to complete the location of rational numbers which are in the form under root n, where n is not a perfect square. That means you can locate root 2, root 3, root 5, root 6, root 7, root 8, root 10, root 11, and so on. This is all about today's lectures. Thank you.